Right, Pete. You straighten your tie? You look right? Okay.
Gotta be tidy.
Yes. Okay, I mean, you touched at the end of that last section really on, it's a bit of a doom and gloom picture. And with any change, there has to be some hope at the other end that something can be done about it. Otherwise we all get into denial or avoidance or high anxiety or go crazy, or whatever, or just distract ourselves. So we're now going to move on to solutions. So perhaps you could just introduce us to that a little bit and then go into whatever you want to go into.
Fine, well maybe we can take solutions in two slices because historically, of course, you're quite right that a lot of this has been around gloom and doom, and in a way that's been pretty destructive from a point of view of the general population, because I think they're inured now to the fact that this doom and gloom hasn't actually materialised, because they were led to believe that this might take years, whereas of course it's maybe going to take centuries. But secondly, that's had the effect of maybe sort of taking it off the radar, and of course with a recession that's very much the case. But if we look at solutions in two chunks, I guess I'd go back to the old trustee, which the human race invariably uses to dig itself out of holes. As a species, we're very good at, through our innovative approaches, at falling into rabbit holes or traps. But then, of course, we rely on technology to get us out of it. And so if we first look at technology, and then associated with that is the whole regulatory framework and taxes which drive the process from governments. And then in the second half, we can look at more detail about how proactively, I think, the role of supply chains, the big brands, the global brands, can react as well, and indeed we can also look at taxes there, but as incentives, the tradable permits and so on. So a bit of input-output economics, if you like. So let's look at the role of technology. And first of all, of course, based on European experience, there's been a very clear remit from the 1980s, 1990s, coming from Strasbourg and Brussels, around the importance of regulation as a first stage mover in this. So even though we don't have data that enable us to understand the scale of the problem for many of these issues, there was an early and indeed continuing reliance on the fact that if you introduce outright bans, classically landfill bans, and prohibitions on certain types of behaviour, then at least it's a start. And most of these solutions tend to be predicated around those sorts of issues. So we've got a whole panoply of environmental regulations in Europe now, which I think certainly many people in the States feel that they're inappropriate to their experience in a slightly sort of differently motivated economic structure. But the Australians, the Canadians, are all, and indeed the new entrant nations in the European economy, and maybe behind them even Russia, are looking to the EU for the framework regulations that they've introduced. And at the moment, those are sufficiently well developed in terms of resource efficiency agenda, doing more with less, or this whole argument around this sort of input-output ratios of resources to sold products, and they're working towards the concept of producer responsibility, which we'll talk about in the next slot. But as a result, those taxes and regulations, most notably in the case of the UK, landfill prices went from around £7 in 1996 with no taxes, to today, where we're looking at 4-5 years later, 15 years later, we've got landfill taxes at £58 a tonne, and landfill gate fees of nearer £82 per tonne, £85 per tonne, depending on where you are. So this is the impact of hard economics that either immediately or in a medium-term fashion send clear signals that if you pollute, if you don't use resource efficient systems, then it would just become more expensive. So the so-called internality pricing signals are bludgeoned into change. Companies that historically used to throw away all their cardboard now at a cost of, well, today it would be ludicrous to put a ton of cardboard into landfill for over £80 is a nonsense, when if you segregate it and you keep it clean and you deliver it to a cardboard reprocessor, you will be paid £150 for it. So these are quite fundamental price signals now.
And they're going to
coming
affect
in.
Not just technology and which technologies people invest in, but also working practices and behaviour, aren't they?
Very much so. What that's done in the UK in the technology context has meant that instead of burying stuff under the ground, there are only three other things you can do with waste. You can either put it on the ground, so that's compost. I tend to think around waste as a carbon. So if you think of it as a reusable carbon, whether it's as a metal or whether it's as cardboard or paper, then instead of putting it in the ground as landfill, you can put it on the ground as compost. You can take it down a thermochemical route to produce heat and electricity, i.e. you either burn it or bake it. And the third dimension is that you can take it down a biochemical route, where you use bugs, much like our stomachs and a cow's stomach, to microbacteria. They can break down that carbon. Now they can't do that with metals, but I think that what I try to do when I'm talking to other people in the waste industry is to get them to think about these products in terms of their embedded carbon potential. Now if you break down those three segments, then of course the cheapest option, where we've seen much evidence in the US, in Australia, and in the Western European countries, sometimes for different reasons, is around biochemistry. The Germans have been using anaerobic digestion, air-starved systems with cultures of bacteria to convert biogenic food waste. It must be clean, it must be free of plastics and aggregates, but you can convert that into a gas, and you can put that gas into an internal combustion engine or into a boiler system to generate steam. And you can use pig slurries. You can broaden your approach by co-mingling forestry wastes with food and conventional industrial commercial arisings with pig slurries, animal manures and so on. So that's one box. In the intermediately expensive box, you've got those technologies that, unlike AD, which operates around 80, 90 degrees,
anaerobic
and
digestion,
is anaerobic digestion, which is a pasteurization process, then you move it up a gear from 350 degrees to around 800 degrees. You're moving into gasification systems, and beyond that, at 1200 degrees, you can use plasma arcs with an anode and a cathode, and you can blast this organic material. And at the lower temperatures, you get methane, CH4, and carbon dioxide, CO2, plus a few other things. But as you move up that temperature scale, of course, the technology cost, sophistication, and the energy input is going up and up and up. But by the same token, you're moving towards a spectrum where at the very top of the spectrum with plasma arc gasification, you're producing hydrogen and carbon monoxide. And then finally, you've got thermochemical systems where you are burning that material in the presence of oxygen. So rather than in air-starved environments where you're producing gases, in the thermochemical process with air, you are producing heat, which takes you to steam, which takes you to steam turbines, so you're producing heat and electricity. And the important thing with all these technologies, which certainly in Western Europe is now coming to the fore, is to create an understanding of what the carbon dioxide impact of these different systems are from the point of collection of the material to its preparation as a fuel feedstock, because anaerobic digesters don't run on the same feedstock necessarily as compost operations. And the same goes for thermochemical systems. So you've got collection and logistics, you've got fuel preparation, you've got fuel conversion, and then you've got fossil fuel displacement at the end. And that is now creating quite an extensive science into this concept of carbon footprinting, so that in net terms we're better off than just burying it in landfill.
Great, Pete. We'll carry on with this in the next section.